I wanted to start off by asking if anyone had questions or anything from any of the videos, the pre-class videos or anything like that. Um, if there was anything that wasn't like didn't get clarified for you from them, or something wasn't explained well enough, or something like that. Apparently, we instructors are that good at making instructional videos. Just kidding. Okay, let's go and get started. So today and I know the schedule has been a little wonky. I think what we will do going forward is, I don't think going forward, we're gonna have the adventure game, the mud. We're not gonna start that until probably the second half of the week. And then the first 2 days would just be devoted to those exercises. So it's just that for whatever reason, it's been taught like this so far. And I think we need to make some changes to this particular piece of curriculum. But anyways, so and in the exercises, we already saw a little bit of object oriented design. I'm mostly thinking of which exercise am I talking about? The one with the latitude and longitude. Was that object py? Yeah, object py. So I already saw in that one. Let me pull that up. Right. So a couple of things were basically showcased already regarding Python's kind of object oriented, the features for object oriented design that Python already makes available. Syntax. Yeah, whatever. Um, so, basically, we've seen how to make classes, we've seen how to write a constructor, and then we've seen also how to do some basic inheritance. Notably, just to refresh our memory, for example, we had waypoint inherit from this lat_lon class, and basically all we had to do for that was to pass that in. I don't think it's a bad structure. Diving right into something as hard as the game is probably good, besides we code something like that in JavaScript. So terminating in Python makes sense to me. Okay. That's okay. I see what you mean. I guess I think one other kind of point. Well, one thing I didn't like when we had all the exercises on the first day was just the sheer amount of time it also took us the morning after to go through all those solutions. Like I don't think we finished until like 10:45, and then we had to rush to go through the rest of the stuff. So I think that's kind of another point in favor of spreading all those exercises out into 2 days. But I can kind of see where you're coming from. 90% of the class. Intuitive success. Okay. I mean, as far as what I heard in terms of like feedback from PMs, it seemed like at least yesterday wasn't too bad for most of you guys. I taught myself French was harder than this. Reflection and study is underrated. Okay, so the zip method on dictionaries. Yeah, I can definitely add something like that. Moves. Didn't print to physical leaves. Yes. Sure. Running files directly using command line interfaces is very neat and a little daunting. Yeah. I can totally see that. Again, unfortunately, that's something we're finding out for the first time because you guys are the first iOS students doing the computer science part. I just don't know if going forward, if that's something that we would address as part of like at the beginning of the CS curriculum, or if maybe that should actually be something that is at least talked about a little bit in the iOS curriculum. Yeah, is there not like a Swift REPL that you can just run in terminal? Just curious.
You can run Swift in the command line. It's
just nobody does it.
Yeah.
Okay.
Also, Swift is compiled. We don't use interpreters, so that's another thing.
Yeah. Shrug emoji. Yeah, we're gonna have to figure out what's the best way to kind of make a compromise there. But certainly I know it's just that, coming from if you're a student coming from the web curriculum, you certainly already know how to run files and code in the terminal. Anyways, before we went down that line, let's just start over. I was mentioning we've already seen a little bit of Python's flavor of object-oriented programming with the object py class or file. Probably, at least I know coming from JavaScript, I think some of the newer things, well, certainly I think one thing you probably didn't see much of in JavaScript was stuff like this __ str method that we introduced. Super, you probably also didn't see too much of. So I know sometimes in React components you would call super when you like extended a React component. Although I'm actually not even sure if that happens very much anymore. I'm just not sure if like some of the newer React APIs have gotten rid of that. But at least because I used to also be a web instructor before I moved to the CS material, but at least when I was teaching it, there were still calls to super, but not really like the way that we're seeing it here, where you would invoke super to get direct access to like the constructor of the parent class, for example, right? React to super regex kind of makes it unneeded, right? Yeah, okay. I'm just like confused because I'm not entirely clued in on all the new React API changes. So I'm just not sure what has changed and what hasn't since last I used to look at React code. What's the user we learned JS inheritance? Yep. Okay. As far as basically what, and again, I don't know how object oriented Swift is. My guess is it would probably like, okay, so like for example with JS, oh, this is okay, this is Swift. Okay. It's not very different. But I guess my question was, I would guess Swift is not, it provides object-oriented features, but it's not completely object-oriented. Like it probably has some mix of functional and procedural as well, just like both JavaScript and Python as well.
Correct.
Calls to super. Okay. So yeah, that's a very common thing now with a lot of modern languages, is that they kind of allow you to pick and choose how much object oriented you want to be, how much functional you want to be, how much procedural you want to be, which makes it so, you know, there's as few kind of constraints as possible on the programmer. Whereas, for example, like Java, you know, everything has to be structured as classes, and everything kind of inherits from everything else. It's just there's a lot more kind of constraint on. There's a lot more constraint that you're basically buying into when you decide to use a language like Java. It's a lot more opinionated in that sense, right? Yeah. And then, as you'll see with when we get to C, uh, there's no such thing as object oriented in C, because C is entirely procedural, meaning I guess the analogy I would use for that is that when we're talking about procedural is like, well, let me back up. Let me back up a bit. So the analogy I would use for any sort of kind of like object-oriented programming paradigm is, well, it models things that you're programming as like concrete kind of things, right? So it's really easy to model nouns, and then it's easy then to also say this is a verb that kind of belongs to a particular noun. And then we can add that verb basically as a method on the noun that it belongs to. It's really easy to kind of do that. And so everything is kind of shoehorned into these strict classifications, right? And then there's a bit of flexibility there with inheritance being like, oh, you can define this really broad class that's really kind of all encompassing, and then have more specific classes inherit from the really broad class. So you'd get like, you'd start off with a really broad kind of base, and then you can imagine it as like this funnel that kind of funnels down if you're getting more and more specific in terms of what your nouns are, if that makes sense. If not, maybe I didn't explain it very well. Procedural is different though, in that everything is kind of like just a recipe. Your code is basically just structured as a recipe, and there's no I mean, you can get away with some really kind of basic object oriented, like you can try to kind of shoehorn in object oriented concepts into C, but it's not baked into the language, and it's something that you just kind of hack together yourself, if that makes sense. But anyways, I'm getting a little ahead of myself. So yeah, I think a lot of you guys are pretty much already kind of familiar with writing in the object-oriented paradigm. And I would actually think that it's probably the paradigm that most of you guys are most kind of comfortable with, right? So again, we saw a lot of that in JavaScript. React uses it a lot. And I honestly think that I personally think that the fact that React leveraged the object-oriented paradigm as much as it did is actually one of the reasons why it has become so popular. Uh, Personally, I think, and I think many people would agree that structuring your code in an object-oriented way is probably one of the easiest ways to think about your code. It just makes it really easy to kind of reason about what you're trying to program when you can kind of imagine uh, things as kind of concrete nouns, right? And then I think that's a bit of a consequence of the fact that like programming is such an abstract kind of activity, and so when you can kind of try to inject uh, as much concreteness into that abstraction as much as possible, it makes it a lot easier to think about. This is why super is in the method definition. Not yet. You're talking about in the code here. Yeah. Okay. I can talk about that in a second. Right. So we've seen a lot of that already. Um, and so what's also really nice about these paradigms like functional, procedural, object oriented, etc., is that because they exist among many different languages, it helps you to it's another thing that you can take from one language and apply to another, right? So again, my point being is that we've seen already a lot of the object-oriented language features that come from either Swift or JS, and now we're seeing it in Python. And I think what many of you probably realized is, oh, this isn't very different at all from what I've already seen. A lot of those concepts we apply here. There's of course again some slightly different syntax for how Python uses it, but the underlying concept is all still the same, and it basically allows you to still do the same kinds of things and has the same kind of strengths and trade-offs uh, from what we saw in our previous languages, right? So as far as going to answering David's question now, so again, just to kind of rehash why we're calling super here. So we see that the waypoint class inherits from the latlon class. Latlon was kind of the independent one, kind of the most generic one, right? In the sense that it doesn't inherit from any other specific class. And so waypoint inherits from that. And what inheritance really means when we're talking about inheritance from a programming context, and what inheritance really means is that waypoint has access to the methods and the instance variables of its parent class, right? Really, inheritance is just about kind of extending the functionality of some other class, right? Again, meaning that waypoint has all of the same functionality as the latlon class, and waypoint then opts to also add some additional functionality on top of that. So or you can think of it as like it's iterating on top and improving upon latlon, or it's becoming or it's just more niche or more specific, however you want to kind of interpret that superclass in Swift. Yeah. So it takes in some of the same parameters that the latlon constructor takes in. It can also receive an additional parameter. And then when we receive the latlon parameters, instead of duplicating what the functionality that latlon already provides, we can just leverage the constructor method of latlon, because we're just going to be doing the same thing with it anyway, right? So another thing that inheritance really helps with is getting rid of code duplication, right? So for example, if we just had lat-lon as its own independent class, right? Dry standing for don't repeat yourself, meaning we want to keep it as a rule of thumb that we duplicate as little code as possible, right? So if we just then had a waypoint as its own class, we would be having to write the same code that's already there in the lat-lon class, but we're just doing the same thing with it anyway, right? So it's just a lot cleaner to just kind of do it this way. And then of course the inheritance is one way direction. I don't think there's any way for lat-lon to leverage any of the methods that waypoint adds on top. So it's kind of going back to that idea of that one-way data flow that we're used to from React, is that the geocache, which waypoint is a subclass, right? So geocache, which inherits from waypoint, and then that inherits from lat-lon. Geocache has the most kind of specific, or has the most functionality in the sense that it has all the functionality of waypoint, it has all the functionality of lat-lon, and then adds its own stuff on top. So inheritance as a means of cleaning up your code, making it more dry, is nice. And then as well, another thing that another aspect, I should say, of object-oriented code is the type classifications, right? So, for example, we can do, I think we can do something like, so let's say print G is instance of, let me check how we use the is instance method again, just to make sure. I should be there. Whatever. I'm assuming that was an instance. Well, we're a subclass of another object. Yep. Oh, okay, that's how you call it. Okay. So we'll say is instance G of did we just type in lat-lon? Let's see if that works. I'm in the right folder. Okay, cool. So that worked. So another thing we can do, or we can see, is that G, an instance of geocache, is indeed, if you throw that into is instance and pass it one of the classes it inherits from, that comes back as true. But we can try the other way. So let's say W is an instance of geocache, right? So W, which is a waypoint, geocache inherits from it. And we're going to see if the waypoint W is considered an instance of the geocache, but it shouldn't. Okay. Yeah, that is a thing we can do as well as what Brian is saying. So for example, we can do class, I'm just going to call it foo, and it can inherit from, uh, this is not going to make a lot of, so it's not going to make a lot of, it's not going to make a lot of sense in this case. Like we could have a class that inherits from both waypoint and geocache, but the idea being that foo would have the functionality of both waypoint and geocache. But in this particular case, it's not really showcasing the value of multiple inheritance because geocache is already an instance of waypoint anyway. So really there wouldn't be much point in doing this. This would be pretty much just as good as if we just had foo inherit from geocache because geocache already contains waypoint anyway, right? So if you wanted to do something with multiple inheritance, you'd probably want the classes that this new class is inheriting from to be not related to one another. Extension, okay. Yeah, I think JS specifically also uses the extends keyword as well. But there's no extends keyword in Python. So here's a question for you guys. Can anyone tell me what's semantic or pedantically speaking when I say, class versus an object, what is the difference?
An object is an instance of a class.
Right.
A class is a data structure for more or less managing objects, but it depends what language you're in.
What if I ask you guys, what does an instance actually mean? In general, Brian. In general. Because in this case, either in JavaScript or Python, the definitions are not going to change. This is one specific item of a type of item. Okay. Sure. So yeah, you guys pretty much all got it correct. Right, the class itself is the specification or the blueprint, right? It's like how I'm sure Apple has a specification or a blueprint for their latest Mac, right? But the blueprint is not an actual Mac. The blueprint just tells you how to make a Mac. And then you have to put in the work to actually make the Mac. And then that was an actual Mac that somebody can actually use and program on. You can't program on the specification of a Mac, right? So yeah, I'm going to drill down a little deeper in terms of kind of right. So what we've seen of class definitions is, well, obviously we define them in code, but then when we actually go and create an instance of one of these classes, right? So like here we've instantiated a waypoint. We've instantiated a geocache. So we have instances of these classes here. As far as the computer is concerned, what is required to create an instance of a class? Right, it's like how we said, again, Apple has a specification or has blueprints for its latest Mac, and then it has to, yeah, okay, yeah, that's true. That's not incorrect. I guess I had something slightly different in mind. Okay, I don't know if people would get this if I just kept asking, but basically, kind of what I was trying to get at is that, you know, when you actually initialize a class, you know, what your computer does under the hood is it initializes memory and actually stores the initial data for that class in memory. Here, let's use a visual. Is this going to behave today? Oh, it's not plugged in. That's why. Right. Kind of what I'm getting at. Of course, people don't really know what malloc is yet, but okay. So, right, you know, so we have some whatever class foo, which is our blueprint, self, whatever. Let's just say X and Y. Right, so again, this is our blueprint. And so what the computer actually does when we initialize this, or what is the actual, how an instance is actually represented by a machine, is in memory, right? So for example, so if we say this is our memory, our RAM, you know, we have the actual blueprint stored somewhere. The actual code, you know, is stored somewhere in RAM. But then also when we go and initialize an instance of foo, this is going to go and get its own spot in memory. And then in here, you know, the x, the self.x is going to be initialized to whatever, and y is going to be initialized to whatever. Right? The memory here, we need this new memory allocated for it because, and to basically keep track of the state of this particular instance, right? And then if we go and initialize another one, that's going to get its own spot in memory because it might have different state that it would keep track of. Well, I'm not going to explain memory too much. We're gonna get into that later. I'm going to keep it kind of vague at this point. We're definitely doing a lot of foreshadowing as far as, you know, what stuff is going to get explained when we get to see and start working with memory more concretely. But this is basically what I mean, right? And so each instance, you know, and this is what we mean when, for example, as we saw in JavaScript, for example, if we had let's say A equals foo, B equals foo, and we did, you know, A triple equals B, we always got false back, right? Because these two instances are different. Like they're not the same places in memory. They might even have different states. They might have different instance variables associated with each one of these. And it's the same in Python, right? So if we do If we do an A double equals B in this case, this will return false for us. And let's just check that. So let's say G is some geocache. H is the exact same thing. And then let's print G equal to H. Yep, that gets, oh, that's this one. So this false, so that's correct. Right, so for example, self-lat and self-lon, you know, all instances of the class are going to have that, but they're all going to have different actual values for lat and lon, which should not be new information. Yeah, getting a bit ahead of ourselves there. And lon do not need default args. Well, default args are being passed in at this point. So if we call the lat lon constructor and don't pass it anything, those are just set to 0. Initial value, I mean, default arguments or initial values are kind of the same thing in this case. You can do that too. In which case, then the function signature would always you don't have to always pass in lat and lon values. You can write our own code in some way to make it so that GUSH returns true. No, I don't think so, and I don't think you'd want that to be the case. Well, okay, sure. I see what you mean. Right. So in that case, you know, what you want to do, you're specifically trying to actually compare values, right? So, you know, you'd have to write a specific function for that. So let's just say compare object values, for example. Right. And then in that case, we could do something like for key value in object 1.items. Let's do if object to key. No, let's do if key in object 2. So first we're going to check if the key is even in there. Then we can do if object to. No, that's a better way of doing that. We can do try object to key equal to the value. Except key error, in which case we could just return false. And then if that entire for loop passes, then we can return true, meaning these objects have the exact same initial values. Deep comparison. Oh yeah, I'm not even considering that. Not even considering that right now. But yeah, right. So you'd have to write a special function to do the actual comparison. So let's try that. It doesn't matter. Print compare object values of GH. So hopefully I've written this correctly, and nope. Okay, fine. Okay. Okay, that came back as false when it probably shouldn't have. Let me see. So we gotta. Oh. Keep on. No, I want if they're not equal. Also return false, I think. Okay, I think that's better. Still false. Here, let me do this a bit more. Let me just make sure everything is. Oh no, I do need to call it. I do need to call that. Geocache object does not return value. Okay. So I want to, let's see. I'm gonna make a special method in the class return dict so I use to compare. Oh yeah, I think you're right. I think you're right. That's a good point. Oh right. Items is okay. No, you're right. Items is a method on dictionaries. I think strictly speaking, these instances are not dictionaries. So we'd have to do something like I don't know. Let's just say let's call it to dict, and then return. So we'd have to do like lat self dot lat line self dot line name self dot name then size self dot size. So return that, and then we can do the check on those. Let's try that. G dot to dict. Oh, nice. That returned true. Yep, that was the last print we had. Okay, good call. Yeah, it was so I was passing the actual instances in as object one and object two, but those are, I guess when I meant objects, I mean dictionaries. But that's not what they were. So we had to go and transform them into dictionaries, right? So that's a little confusing. So I guess lesson learned here is that JavaScript would represent the class instances as actual objects, because classes really are just kind of syntactic sugar over JavaScript's objects. However, that's actually not the case with Python classes and instances. Python classes and instances are not dictionaries, even though dictionaries are basically the same thing as JavaScript's objects. So that's a little bit of a gotcha there, right? So we saw we had to take the class instance and tell the instance how to represent it itself as a dictionary, and only then were we able to go and compare the values. So that's a little as an assignment curious what underscores for some function. Yeah, so you can think of those as private methods to, well, basically private methods that each class has that you can kind of override in a way, right? Well, the best way to explain it. They're kind of like Python's magic class methods. So for example, init is the constructor, and Python does some magic under the hood when you specify a method called init. It does stuff like for example, whenever you call an actual constructor, and we just say L equals lon like that, even though the constructor takes self as an argument, as we see here, we don't actually have to pass anything in it. So init does some magic where it can figure out what self is and then pass that self argument into the init constructor, for example. And also with underscore string, this particular function is hooked up in such a way that I think if we did, well, as we saw, right? So what we did previously was when we initialized a waypoint or geocache instances, we could then just print geocache G, right? And normally, if we didn't have a definition for the underscore string method, Python wouldn't know how to print this, how to represent this this class as a string, because it's a user-defined class. How is it supposed to know, right? So we can leverage this to define how we want it represented. And then Python knows that once we've defined an underscore string method, to take this and use it every time we try to print out an instance of the function, of the instance. I know there's a whole bunch more as well. I know there's another one called repr, which I think stands for like represent or something. I think it's typically used pretty interchangeably with string. Both of these are just ways in which you tell Python how to print out or display the instance. And actually, well, now I'm curious about str versus string and repr. I was talking some of the syntax in Objective-C. Okay. Oh, okay. They have different goals. And it seems like these pertain to different aspects of the Zen of Python, which is interesting. Repr's goal is to be unambiguous, but string's goal is to be readable. I see. So kind of the way I interpret this is that Repr might be a method you would opt to use if you wanted to define a representation of the class that's better for debugging. So if you know that if some, for example, someone wanted to debug some issue with the particular instance, maybe you would define a particular way of representing the instance specifically for debugging. You know, you might include more information than what you would with like the underscore underscore string, which then you might think of would be the method you would use to print out a user-friendly, readable representation of the class. At least that's how I interpret it. From just what they say here. Unambiguous meaning, you know, you kind of see all of the gory details. But then string maybe can hide away some of those details and be more user-friendly or user-readable. But I think I see a lot of times these are pretty much just also just used interchangeably. So maybe it doesn't make that big of a difference. Okay. I think now is a good time to take a 5-minute break. And then when we come back, we're going to start looking at the adventure game and maybe think a bit about how we to leverage some of these OOP principles when defining, like, you know, our player in our room. Like maybe, for example, we want to do something like define a bunch of classes that might all inherit from the player. How do you compare with the same set of function names with different function content? Are you talking about? Talking about function names specifically? Oh, wait. So do you mean like? So again, class foo. I don't know, some init. I'm just gonna say. Tell this after, sure. Okay. Yeah. All right, let's take 5 minutes. Talk about access control. Okay, sure. Instance, let's see. Okay, coming back and reading size question. I think again, I think one thing you're maybe slightly confusing is that again the fact that in Python classes and instances of classes are not syntactic sugar over objects, right? So in the case of comparing class instances in Python is pretty different. What is a deep comparison? A deep comparison is when we, for example, let's say we have an object. I think this would be more like JavaScript syntax. If we had, nested objects, or oh come on, C, D, whatever, et cetera, et cetera. Deep comparison means that we'd be checking all of the layers of the object against another object, right? So if we had two objects with the same sort of hierarchy and all the same sort of data, then at that point they would be considered equivalent in the sense that they all have the same values, even if they're residing in different parts of memory. But that's okay. Yeah, no worries. You're good. So yeah, that's what we mean by a deep comparison. It's just usually I guess another kind of rule of thumb you can keep in mind is just like when we're talking about comparing objects, I think maybe there's a little bit of an implicit expectation that it will always be a deep comparison, right? Meaning that we never want to just check objects one level deep. If they contain deeper levels, those we would all want to check as well. And I think some languages, when you are doing comparisons of objects, it will implement that for you. So just as an example, let's do so let's say, man, would you stop? So let's say for example, I think if we do print, we do this, so we do this in Python, run that syntax error. Oh, line 16. Yep. So yeah, Python will perform deep comparison for us automatically, as we're seeing here. So here it understands with when we're saying equal for dictionaries that we mean check the values and check that the keys and values all match, instead of being like check whether they're the same spot in memory. So it'll do that automatically for us, although I don't know if every language does that for you. Like I'm not actually clear on if we tried doing the same thing in JS, whether that would work with just double equals. I'm not sure. I'd have to check. Okay. Same set of function names. But I don't even see how that could be possible because functions on classes are shared between all of the classes, right? Like if you're defining some content, what or do you mean to say that the if two instances of geocache have different values, but that the actual definitions of the functions are the same, right? Because you can't have two instances of the same class where one has a function that's the same name, but the content of the actual function itself is different because functions are class specific, right? They're part of the blueprint. And so any instance you spin off of that one class is all going to have the same function bodies. Although the values for example, difficulty size, name, and lon values can be different on a per instance basis because those are what are called instance variables. But functions will not change on an instance basis. Actually, I want to compare instance to different. That had different. So you kind of just mean like a foo with and like say a string. I don't know. Let's do that, and then you like just the same thing but with like a different name. Same function names or different function content. Oh, pass is just it's like how, you know, like in JS, if we had like some like if we just do this in JS, right? Because we have the curly braces and we can say don't put anything in there and it doesn't do anything. But because Python doesn't have braces, it just needs some other way to represent a set of like empty braces to mean this function is not going to do anything. Pass just means this function is not going to do anything. It, again, it literally just means it's like the same as like an empty set of braces. Same function names with different function contents. So I don't know, like return X, return Y, return A, return B. I don't think there's a way to do that. Frankly, I was kind of not sure why you want to do that. I guess. Basically, you just want to check to see that the functions available on classes are all named the same thing. Yeah, sure.
Well, can you hear me?
Yeah.
So, sorry. Maybe I'm making this a little bit too complicated. But the reason I asked is if you could scroll that up a little bit. Earlier in line 49, when you do the compare object values, you're only comparing the keys and values that object 1 and object 2 will produce. But if you scroll up a little bit more, so this will only happen when you have something defined in a class, say line 29, you have that to dict, right?
Mm-hmm.
So I was just thinking that how do you compare instances of two different classes that have the exact same set of functions, you know, the underscore init, underscore string, or even the to dict, but then whatever they return are slightly different.
Right, I understand that part. I don't know of a way to do that. Because
Okay.
again, comparing classes in JavaScript versus comparing classes in Python are different. Because Python and JavaScript implement their class systems in different ways. Because again, JavaScript just implements its class system on top of objects, but Python does not do the same thing. So it's not as easy to talk about comparing classes in Python.
Okay.
Because you saw what we had to do is we had to convert the entire class to some dictionary, to some format we could actually compare. We can't just go and compare the actual class instances.
Okay.
Python doesn't really have a notion of that, as far as I'm aware.
I see. I actually have a question that kind of relates to this. I didn't get a chance to type it out. Is that, let's say if you have a parent class, like in this case, what was it, latlon?
Mm-hmm.
Or let's just say waypoint.
Sure.
Let's say waypoint have a method also called to dict.
Sure.
And then let's say, you know, it returns something that's a little bit different than what the to dict returns in geocache. So when you have an instance of geocache, and then you try to call let's say h dot to dict,
Yep.
how do you differentiate which function it actually calls?
Yeah.
Because you know how like in JavaScript you have you can do this dot and then the function versus this dot props dot the function. This way you can differentiate which function to call, whether it's the, you know, even if the function name is the same in a parent or self, the class.
Sure. Okay,
Does
so
that make sense? They kind of relate to me. I'm just trying to find a way to differentiate and compare the methods in different classes.
Yeah, I understand what you're saying. Okay, so that's a good question. I guess one aspect of inheritance that I didn't really mention. So now we're seeing we have a to dict on both waypoint as well as geocache. And the way inheritance works is if geocache inherits from waypoint now, as we said, it gets all the functionality of waypoint, which includes this to dict definition. So we can comment out the to dict here, and we can go and call, we could say print h dot to dict on a geocache. So we can run that, and that would work. or that's this one. That's this one, right? But the main difference is, well, the difference between these two definitions is that obviously on waypoint, it doesn't print out the difficulty and the size, right? So in geocache's toDict definition, it prints out difficulty and size. And so now just when I go and uncomment this, and now we go and run this code again, the dictionary returns is different. Now it prints out the difficulty and the size because it is now calling the toDict method that we define specifically on geocache, right? So method overriding, when we talk about inheritance, is in play here, right? Both of them have a method called toDict. And by default, if we don't define a specific toDict on geocache, it's just going to fall back on its parent's implementation, right? So that's what we saw happened here. We were still able to call toDict here. So self-function always takes precedence over. Yes. If we go and define, like, and specifically we have to call it the same thing, specifically to override the parent's implementation. So like, for example, if we called this something different, like say geocache toDict, then we could still call h2dict here, but that's going to call the parent's toDict, and toDict is not going to be overwritten on the geocache instance. So we can still do that here, prints out the waypoints version, and then we can do print h geocache toDict. And now it'll print out the two different versions side by side. But I guess there's not really much point in having geocache have its own specific geocache toDict that does not override the parents in this case. So it just makes more sense to just say, okay, we'll just have geocache every time it calls toDict is just going to print out the information that's relevant to itself. But yes, any function you define, any method you define specifically on the class itself is going to take precedent over its parent's definition with the same name. Use parents function in terms over. Can you? That's an interesting question. I've never thought about that. Let's see. So if we did, I think maybe what you could do. Okay, so let's try this. So maybe we could do something like super dot to. I don't know. Let's see what happens. So I guess if we do that, it should print out. I don't know. Let's see what happens. Okay. Let me get rid of some of the other print calls. So yes, I guess we were able to. So we printed out the parents toDict ran and got printed out, and then the geocaches went and got printed out. Interesting. Okay. So in order to compare the functions in two different classes, we need to put yeah, I guess you could do that. Yeah, you somehow have to stuff it inside of a dictionary. But then even then, like the only way to kind of inspect the function bodies is to read the code for them, I guess. I don't know of a way to comparing functions is a I don't know if that's something that's done much besides just inspecting the function bodies and reading them. I think Sai is probably just curious, but I don't know. I don't know. I don't really see a use case for this myself either.
Yes, I am. Sorry.
Okay. He's just curious. No, it's fine. Okay, cool. Nice. So let's go and talk a little bit about, that's not what I'm looking for. Oh, here. So let's talk a bit about, let's see some of these principles in action with implementing like a player class. Well, so we can just go class player holds information about what room they're in currently. Okay. So we can go init self current room. Current room would just be current room. Okay, that's all it tells us we need to include, but you know, we can I think we've all played games. Most of us have probably played MMOs or some sort of RPG. You know, we can add some additional things on top of this player class. So like health, we can default to 100, mana 50, maybe not even mana. You know, maybe we want to do something like different classes will have different energy types. Like rogues had energy and warriors had rage, and then other classes had mana, et cetera, et cetera. You know, so maybe we don't even want to just say every player is going to have mana, right? That might be something that's more specific to like different classes. Maybe we'll have self.inventory. And what else am I thinking of? Maybe like movement speed. Let's just go, I don't know. I'm going to default that to a number. Maybe 20 is too fast. Let's say 10. Right? For example, function that brings up a map. I'm just thinking if we would want that on the player class. I don't know if we necessarily want that on the player class. That is something we would want, for sure. Although, keep in mind, here we're just implementing a text-based MUD. So we're not in like actual World of Warcraft. So I actually don't know. I mean, I guess we could still bring up a map. We could still bring up a map. Maybe there's like a command that a user could type into the MUD just says map, and that would bring up like an ASCII version of the map. So okay, maybe that could be a thing. I am not sure whether we would want that on the player, right? So we kind of want to think about what the player actually, what sorts of functionality the player class actually encapsulates in this case, right? Here, the player is the representation of your character. As an aside, never played any of these tutorials and just learned what MUD means and still know what. Oh, MMO is massively multiplayer online. MMO is short for MMORPG, so massively multiplayer online role-playing game. Basically an RPG you play with a whole bunch of other people. Anyways, So that might be a good place to start as far as like an initialization for our player, and then maybe we'd want to go and implement some functions, some methods, right? So maybe, for example, pick up item, because we have an inventory item, right? And this could just be self.inventory.push or append the item. And then maybe like a try move function, right? And again, this is kind of specific to our text-based multi-level user dungeon or multi-user dungeon because there's no visual component. You know, when we type in a direction, we don't necessarily know if there's a direction we can actually go in, right? So it's a bit of a different paradigm in that sense, right? So let's say direction and well, we already have current room available, so we can do the just kind of like that. Try move, and then well, we'd have to have access to the room class, because here we're going to be interacting with room. So maybe we'll want to do from room import the room class, which we haven't defined yet. At least we haven't here, right? So maybe in this case, then we can say direction. To clarify, do you have self as an argument so we can access this own property? Yeah, right. We always have self in these methods, so we can always just access any of these attributes from any of these methods. Yes, right. So if we want to do try to move in a direction, let me add some comments. So here we're going to try to move in a direction or print an error message if the player can't go that way. Oops. Well, I'm just thinking right now, maybe we should go and define the room first. Yeah, let's take a quick detour and go and define the room class first. Implement a room class. Should have name and description. And we'll just keep it as that and not do anything more than that right now. And we can see when we go to the adventure, to the advpy file, it's importing room from room, and it creates a bunch of rooms. So as we mentioned kind of yesterday, room outside, and then this is the direction, right? So outside, to the north of outside is the foyer, et cetera, et cetera. So as far as how we would actually move, we're going to have to take this into account, right? So for example, if the user types in N for north, we probably have to append, well, what I'm thinking is we could do so maybe direction is just going to come in as just like a single N or S or E or W, right? So let's just say D is going to be direction plus in a string _2, right? So then that will be in the form of what this attribute is actually expecting. So easy enough, we can do that. Or direction because WST. We could do that too. That would take a little bit of extra parsing for us to handle. But yes, that is totally possible as well. Depends on how you want to implement it. Someone unmute because they had a question. No. Okay, and then to do the actual check to see if we can move in the specified direction, how would we do that? Right? So what does it mean to be able to move in a direction? So for example, here, if we're looking at the foyer, we see it has a south. We can go south from it, we can go north from it, we can go east from it, but we cannot go west from it because there's no W_2 attribute on the foyer room. So the way we could do this check is we can use a Python function called hasAttr. So we can do if self.currentRoom hasAttr D, I think that would work. Or I should say if not, right? So again, that means that if it does not have the attr, that means we're trying to move in a direction that we cannot actually move to. And if that's the case, we can print something. Can't go that way. Return self.currentRoom. Else we can say self.currentRoom equals self.currentRoom D. Would that work? Maybe. I'm not sure if we can check that though. Yeah, we don't even have a game loop written. So our game at this point is not even capable of handling parsing or anything like that. So I'm not entirely sure if this is correct, but this is the idea. I mean, I'm not entirely sure this code would work exactly in its current form. But again, that's kind of the idea. Use brackets. Yes, you can. Oh, I didn't even see your question, Brian. Do I still play WoW? No, I haven't played WoW since high school. I think I stopped with Wrath the Lich King with my level 80 Gnome Warrior, if I recall correctly. No, I'm not. Finish with my file grokking Python add-on. Okay. Files.py be getting errors on syntax. Okay. What is it? What is it telling you is the syntax error? Oh, you're just trying to run this code. Okay. It looks like you don't have. Do you need a space after the def? Because it looks like you just have def straight underscore underscore. I don't know. This looks like one thing that might be an issue. Maybe tried that. Sure, if you want to. Sure, if you want to share your screen real quick, we can take a look. So I unshared, so I don't know if you should be able to share now.
Yeah, I'm trying to say host disabled sharing. Host disabled is in the sharing.
I think I have to make you co-host to allow you to share. Sure, I can do that. So I think you should be able to share now. Okay. I mean, I think you will still need a space after the def at any rate, even if that's not the actual problem. But oh no, not after that just after def. So same with on line 12. So you try to run this and it doesn't work in the interpreter. Did you save?
There we go. Sorry. I should probably keep this unmuted while I'm sharing my screen. Can you hear me?
Yeah.
Okay. I can save this. I got to go back in.
Hold on. You don't line 12. You don't need the init there, right? The name of the function is pickup item.
Right. The actual initial syntax error was on line 6 with the colon.
So did you save your file? Because I see the little blue dot at the top, which I think means you haven't saved it. Okay, there we go.
Yeah. I guess you can't see my terminal. I need probably a moment to get into the. Okay, so Python 3 layer.py. I guess you can't see my terminal, huh?
Can you like drag it over where you're sharing, or can you like? Oh, there we go.
See that?
Yeah. .py trace back. Blah blah blah. It's still. It says name error, name def init, but it says def with no space after the init, so it's still saying that seems to be the issue. You see where it says name error?
Yeah.
Oh no, that's coming from room. That's coming from room.
Yeah. So
you need the space there, and then you need the colon at the end of the function, and then you need to go and indent lines 6 and 7.
Yep.
I think that should work now. If you try that.
So, I think
it worked. Yeah, it worked. But it didn't throw up any errors.
Yeah. Okay, cool. Thank you.
Yeah. Cool. I can. All right. So I guess before we, I guess one thing I wanted to also do. As I thought it'd be cool to like implement some more specific classes. So, and have those classes all inherit from the player class. Okay, so let's say we go and do, let's go and implement like a warrior.py. Right, so here we could say we're going to have it inherit from player, so from player import player, class warrior inherit from player. We'll just have it go self. So, and again, the player class already handles all the logic of where the player currently is. So the warrior class doesn't need to worry about that, and also doesn't have to worry about inventory or movement speed. Warrior can just kind of focus on things that make it a warrior. So maybe like self.weapon would be some weapon. I don't know. Maybe it'll have like, or I should say, let's go main weapon, second weapon for like its offhand. Just like shield, for example. And then maybe some stuff for armor, right? So maybe like helm, or maybe we'd have to be a bit smarter about Thunder Fury, about how we want to handle the inventory, for example, right? And then we could also give it a method like some sort of skill, like enrage. Here we could do self dot health plus equal 20, for example, and then maybe also increases movement speed plus equal 5. So that'd be like one skill you could have. As far as implementing like a taunt, we don't really have an attribute yet that is. So maybe we could have something like self dot aggro level that maybe could start off at like something low like 10, and then, you know, other enemies and stuff would have to take this into account. So like when your player walks by, maybe based on your aggro level, you know, that will change the interactivity of enemies around you. And then we could do taunt self.aggro level would increase to like 90 plus equal 90, for example. Oh, and then energy as well. So right, because we didn't define a energy source for him. Maybe let's call it rage. So and then we could do something like, well, obviously enrage and taunt are going to take some energy to use. So if self.rage, let's say enrage maybe takes 5 rage. That makes a lot of sense, but whatever. Else we can print not enough rage. Same thing with the taunt. Let's say this takes 10 rage instead. Same thing here. You know? And the last 5 minutes for funsies, let's, what class should we implement next? I was thinking rogue or maybe a mage. Mage. All right, fine. I'll do a mage. So player import player. So a mage would have mana. Start off with 100 mana. And some weapon stuff. For commoners like me, what is that? Oh, that is basically the priority with which enemies will like decide to attack you or not. Right. So if a character has a really high aggro level, that means that enemies are going to prioritize that particular character over some other character with a lower aggro or priority level. I don't know what other. I can't really think of what other attributes we want to add on the mage. Mana. I mean, we could add all the stats as well, like intelligence and I don't know. Let's go 150 and like strength and blah blah blah. Spell slots. Well, here I'm just implementing the spells as methods on the mage class. So Frostbolt. Say self and target. So if self.mana, say Frostbolt takes 20 mana. And if it does, we can say target.health minus equal. Let's make it a little bit RNG based. So we can import random, and then we can say the target is going to lose some amount of health between some range. Rand range, let's say 30 to 60, for example. Have mage inherit from some spellbook classes as sorcerer. Hey, make sure we get a double inheritance. You have a mage inherit from some spellbook class. Yeah, you could do that. And then also target dot movement speed equals, let's set it to like 1, or let's say 2, for example, because it's frozen. Oh, a blink wouldn't really work. A blink wouldn't really work in a mud, just because there's no. Are we gonna make monsters as well? Sure, why not? We still have a few minutes. We can whip up a monster class real quick. So let's say. I guess it would make more sense to do. I'm just wondering if NPCs and enemies would be different classes. Sure, let's just do a monster so there's something for our classes to fight. So I guess monster would be its own class that wouldn't necessarily inherit from player. I guess it would also need a room, though, to place it in a room. So self dot. Let's see. So let's say I also need health. Let's give it just 50. Movement speed. I don't remember what we gave for player. Movement speed is 10. Okay, let's give it like 8. And let's say maybe I didn't grow up playing games, so I have these. Yeah. The range when you come back, because I get the point. of the game. Lost in these fantasy references. I see. It's just yeah. I guess apologies for those of you who don't get the references. I don't know. Let me see. For accessing properties and brackets, use that outside of a method definition. P equals player room, R equals. Current room. Gives the error to string indices. String. At which line? I'm guessing the r dot n underscore 2. The last line.
I've never seen using brackets as accessing properties because it's not a thing in Swift. So I was curious if you can do it outside of method definitions.
Oh yeah, you should definitely be able to do that outside of method definitions.
Could you maybe show an example? Maybe I'm typing it wrong or something.
Sure. So let's just do it in the REPL. I don't want to do that. So let's say so let's not do anything there, and then let's call. Trying to think of an example. Actually, let's just go with the room definition. So room. No, it's fine. Let's do it from this file. So let's go. Name, sure. So outside, description outside. And then say, okay, let's try. Or let me go and initialize multiple rooms. I think there's some here. So let's take that. And let's take one more. Okay, so we have a bunch of rooms, and then let's say, well, oh, I see. So we can say, yeah, r dot n2 equals, let's try that. So f dot south is going to be r, r dot, let's say r dot east 2 is the treasure room. And then, sure, let's just try that. Couple objects no attribute s underscore 2. Wait. Line 16. But wait, the first line is fine? Interesting. Object is no attribute. It's custom name variables, but no, I'm just doing it here for just for shorthand. Why is it doing that? That's interesting. Okay, what if we, okay, let me see, print r.n2 happens when we do that. Sure, okay. Let me quickly define a wrapper print return rate. Oh, should return that. Okay. So that worked. What is wrong with this? Why is it a tuple? It's the exact same sort of definition. Is it? Oh, is it the? Does it have something to do with the spacing? No, no, it's not. It's just this one. It's just this one. Oh, okay. What? Where is S? S is just a attribute I'm defining on the room F. We're giving the room class an S2 attribute right here on line 17. Yes. Because I didn't give R an N or East attribute either. Yeah. So let's do, okay, let's do print is instance R of room and print is instance of F room. At least let's make sure that they're both rooms. F is not a room. Okay, why is that not a room? Oh, there's a comma here at the end. Was that really it? That was it. That was it. There was a stinking comma at the end of the definition, so I thought it was a tuple or something. Oh, that was it. Okay, so this works now. So we can just add an attribute s_2 on the room class like so. Set that to another room, and we can do the same with west2 is going to be R. Yeah, that works now. Does that answer your question? Who asked that? Andrew.
Not really. Because in your method definition you use brackets.
In the method definition
for the player. Here, let me.
For the player, you're talking about player.
Yeah. So you did this self.current room. So line 25. Self.current room equals self.current room bracket D.
Yeah.
So I'm curious if you can do that outside of a method definition using the brackets, because you're passing in a string D to access that property.
So I guess that would be something like, so if we said P equals player, we are, okay, let me again initialize a room real quick, just because it needs it goes room, and then player is going to be passed the room. So we can say print p dot current room, I think. So let's try that. Player name outside is okay. Yep. So we printed the room, and then we can do p dot current room. Sorry, I have to make another room. Where okay, so we have the foyer p dot current room equals foyer, and then go and print p dot current room. Well, I guess that didn't answer your question either because I didn't use bracket notation. I mean, you could do, I think you could do that as well instead, and this should still, nope. Player does not support item assignment. Interesting. Okay, so that's a syntax thing. It only wants you to do assignment.
Well, let's say that like at line 33, you set current room dot n_2 equal to room or something, and then you do.
Yeah. Okay. Let's do this.
So that it matches what you do in the method.
We'll say foyer dot. That is not subscriptable. Okay, maybe you're right in that. That doesn't work. That's not going to work though. Why do we have access to the room classes? Oh, because we imported them. Okay, let's actually try the p dot. Okay, so hold on. Player's current room is in the foyer, so we can try calling the try move here direction south, right? Yeah, so that should take us to room, and then we can again print. Wrap that in. Okay, so yeah, we can't do that. But at the same time, I don't think that, is that gonna work? I feel like that's not gonna work either. No, that doesn't work either. What? I'm gonna look at this some more. I know I've kept you guys way late. So I'll let you guys go from lecture and I'll keep looking at this and post an update. Sorry about that. But yeah, thanks guys. Cool. I will talk to you all later.